We start off with a graph that we know. Y equals the absolute value of x. We then look at, and I'm going to skip some of these, okay? I'm going to skip the second one and go right away to the third one, because the third one is something we just did. Can you see that in that third one we have a vertical compression? There's a 1/4 in front. And we have a horizontal compression with a 2 inside. Your x values will be multiplied by a half. So if I took this point 4, 4 on my original graph, can you see on the green one, if y is multiplied by 1/4 and x by a half, I would have 2, 1. Is everybody okay with that? Now, as I switch to this one, can you see that that is the same thing as the green graph, except now we have x plus 3 inside instead of just an x? And that x plus 3 is inside the function. And what happens when something's inside? It affects it horizontally. That plus 3 is going to move it 3 to the left. So now my green graph has to get moved 3 to the left. So I'm going to have a point here. Oops, there. And finally, this last graph in purple is exactly the same as the orange graph, except now we have a plus 4 at the end. And that plus 4 is not inside our absolute value, but outside of it, meaning that it affects it vertically. Plus 4 will move it up 4. So our final orange graph, to get the purple graph, we have to move things up 4. 1, 2, 3, 4. And there's our final graph. Now the question is, if we are asked this right at the beginning, graph y equals 1/4 absolute value of 2 bracket x plus 3 bracket absolute value plus 4, right from the beginning, could we do it? Do we have to draw the green, the orange before we get to the purple? Or is there a way that we can just go from our original graph, which is the red one, right to the purple one, without having to graph little things in between? Okay? Yes, we're going to look at how we can do that. Why is it nice not to graph little things in between? Well, for one, it gets your graph, it gets really complicated and messy, and if you don't have enough colors, it just can get confusing. And two, it takes a long time to graph everything slowly. Graphing already, lots of students don't like graphing because A, it takes up so much space. If you were doing your own notes, wasting so much space. And two, it seems to take longer. So let's look. How could we graph this right from the beginning? First of all, we're going to look at going through here. You would recognize that oh, there's an absolute value in here. My parent graph is the absolute value of x. I know what that looks like, and I know what points are on that graph, because that's one of my key graphs. I then look at each of the things. The 1/4. We've already said that that's a vertical compression. That's going to multiply y by 1/4. I'm going to switch colors back and forth just so that things don't get too messy. Next, that 2, we already talked about that being a horizontal compression. That's going to multiply x by 1/2. Three, we've got a +3. It's still inside the absolute value, so it's still horizontal. That's a horizontal translation. That will go 3 to the left. And finally, the +4, that's a vertical translation. That will go 4 up. How can we do all of these together? Well, what we're going to do is we're going to take our original graph, some key points from our original graph. So obviously, I need to take 0, 0, because on my absolute value, that's like the vertex. That's a key point. That's where it changes direction. I'm going to need 0, 0. Now, in order to get the shape, I'll probably need a point to the right of 0, 0 and a point to the left of 0, 0. The one that I labeled on my graph to begin with was 4, 4. You might say, oh, I can see why you chose 4, 4, because you knew you had to multiply your y coordinates by 1/4. So 4 ended up being a nice number. If you don't like nice numbers, you could have picked other ones and had fractions. Perfectly legal, perfectly fine. Although most people like to work with whole numbers rather than fractions, so if you can make strategic choices at the beginning, sometimes that can help you out more. But the main things that are going to cause you to run into fractions are vertical compressions and horizontal compressions, because you have to multiply by a fraction. So choosing a number that gives you nice numbers can make your life a little bit easier. So in the same sense, can you see that choosing the point -4, 4 would be a good idea as well? Now, up till now, we've been doing these arrows, no problem. But what we're going to find now is there's a lot of things that have to happen. And so we're going to do it in 2 steps. We're always going to do our, and I'm just going to write stretches, but it also is compressions, it also is reflections. We're going to do that first, find out what point we get, and then do our translations next to find our final point. And what's really nice is that's just like working from left to right, just like you would read. If you go from left to right, you always hit all your stretches and compressions first, and then your translations afterwards. So then above this first set of arrows, you look, well, what were my stretches and compressions? I had to multiply y by 1/4 and x by 1/2. So I'll write that just above here so I remember what I need to do. If I multiplied y by 1/4 and x by 1/2, I would get 0, 0, 2, 1, and -2, 1. Then for my translations, still going from left to right, I'm like, oh, I need to go 3 left and 4 up. So I'll write that 3 to the left and 4 up above those arrows. 3 to the left, negative 3, 4 up, 4. 3 to the left, negative 1, 4 up, 5. 3 to the left, negative 5, 4 up, 5. So what it's saying for that purple graph is if these were points on my original graph, these would be points on my final graph. Where is negative 3, 4? 1, 2, 3, 1, 2, 3, 4. Right there. Where is negative 1, 5? Right there. Right there. Whew. I was really nervous that when I'd get to those points, they wouldn't match up with the graph that we had to begin with, and it'd be like, oh no, we have to restart everything. But it worked out. Can you see that doing these arrows and translations and transformations together from your original is a lot nicer than drawing graphs in between? And it's going to end up being faster. It's still good to check in the end. Does the shape still match up? Does it still look like an absolute value graph? Because if something went, I don't know, if it's all over the place, it's telling yourself, I probably made a mental math error somewhere. And then you're going to either have to check, or sometimes mental math errors, it's better just to say, okay, I'm going to start over again. All right, let's skip over this one and just go right away to our first example. Here's a graph of g of x. We want to sketch and label its image after vertical compression by a factor of 1/3. So that means we're going to be multiply our y values by 1/3, and then a translation of 2 up. So we're going to use the system where, starting with the points, then do our stretches first, translations afterwards. In this case, I've got negative 5, 3, negative 2, negative 3, 1, 0, and 4, 6. Those are the 4 key points on our first graph. I'm going to just have the whole setup here. 2 sets of arrows because we're always going to deal with our stretches, compressions, reflections first, and then our translations. In this case, we have both. We have a compression. Y is getting multiplied by 1/3. And then we have a translation. We're going to go 2 up. Both of those things affect only the y coordinate. So I know that my x coordinates here, they're all going to stay the same. But my y coordinate's going to become 1, negative 1, 0, and 2. Then for my next one, again, I'm only changing the y coordinates, so my x coordinates all stay the same. And then moving things 2 up, this will be at 3, this will be at 1, this will be at 2, and this will be at 4. Labeling those points now. Okay, -5, comma 3. That stayed the same. -2, comma 1. 1, comma 2. And 4, comma 4. Join our points together. Does it look like it's been squished vertically and then translated up? So again, at the end, we do a quick check. Does it match up with what we expected to happen? Sometimes you just sort of like are kind of estimating, yeah, that looks about right. And we have our final graph. Now, we are also going to do, we've done this one, but there's something special that happens with the example here as well. So we are going to do this example off to the side as well. I know that your solution is written. You can just watch. The idea is the same. Okay? Ooh. First of all, I want to do one thing on this one. Just to finish it up, I'm going to write the equation of this in terms of g, just to practice that. So our blue graph, vertical compression by 1/3, translation 2 up. Those are both vertical things. They happen outside of the function. So my blue equation would be y equals, the vertical compression would be a 1/3 out in front. My function is g of x. And then a translation 2 units up would be +2. Our horizontal one. This one has a horizontal compression by 1/2 and then a translation 3 units up. So once again, what points did we have to start with? We had -4, comma 3, 0, comma -2, 1, comma 5, and 4, comma 2. We do have a stretch or compression and a translation, so we'd have to set up both sets. And we can write above the arrow, we have a horizontal compression by 1/2. That means your x values are multiplied by 1/2. So when it's described in words, nothing changes. Horizontal compression by a factor of 1/2 means our x values get multiplied by 1/2. Yes, did I label a point wrong? Oh yes, it's 2 and 5. Thank you. Check this out. You would never notice. Now, our x values are multiplied by 1/2. Then we're going 3 to the left. So our y values aren't changing. I'll just rewrite all of those. And our x values by 1/2. So this one will become -2, stays 0, 1, and 2. Then we're moving things 3 to the left. So our y values, again, are not changing, so I'll write them all down. 3 to the left, -5, -2. Oh, that's 2 to the left. See? See how easy it is to say, it's easy math, start thinking about the next thing, and then you don't pay attention? Okay, 3 to the left. -3. -2, and -1. We can label those points. So -5, comma 3, -3, -2, -2, comma 5, and -1. Whoops. That point is hard for me today. And -1, comma 2. Has it been compressed horizontally and shifted to the left? It seems to match up. Now, with this part, I didn't need to show you this, because you're like, Mr. JR, that's exactly the same as we did on the question off to the side. So really right now, since I'm paid attention so well in the first one, that I didn't need that. But this is where things get interesting. We're going to write an equation for the blue graph. And I did this before. I'll give you two options. They're either both right, both wrong, or one is right and one is wrong. Okay? Here are the options. The option in. Option 1, in black. Okay? X by a half, 3 to the left. That all has to happen inside the function. Ooh. Should I give you 3 options? Yeah, I'll give you 3 options. So they could all be wrong. They could all be right. 1 wrong, 2 right. 2 wrong, 1 right. Same thing as last time. Option number 1. It's all happening inside the function. So there's inside the function. We have x by a half, but we remember it has to be the reciprocal. So it's 2x, 3 to the left. We remember that that's the opposite sign, plus 3. Okay? Option 2, in purple. We have everything inside the function. We're multiplying x by half. So we put a 2. We need to go 3 to the left. So we write x plus 3, but this time we'll put that in brackets to keep the 2 and the x plus 3 separate. Option 3 in orange. Still got the 2. Wow. Can't even read that. That's terrible. Option 2 I'll put below. That's not orange anymore. In orange, y equals f of 2x. We're going 3 to the left. We'll write 6. Okay. Are they all wrong? Are they all right? Are 2 of them right and 1 of them wrong? 2 of them wrong, 1 of them right. Make your decision. Okay. We've got wrong, good, good. Oh. What happens? So at the bottom of this page, I want you to write this special note. And in the special note, you're going to say, when you have a horizontal stretch slash compression slash reflection and a horizontal translation you must write the equation in factored form. What does that mean? I'll scroll up in a bit. I'll let you write that down first. What does that mean for this equation? Which is probably the best factored form? Of the two that are written, can you see that that 2 is factored out of the x plus 3? Can you see that these two are the same if you distributed that 2 or if you factored the 2 out? Y, the purple, and the orange one are the same. But you're going to want to write the black one. Okay? But that black one doesn't move it 3 to the left. If you look at the very first example that we did right at the beginning of class, see it was written in factored form. The 2 was separate from the brackets. Okay? This comes up so often. They give you the equation and it's not factored, and you have to factor it first before you figure out the translations. And it's something that is so easy to forget. I had a student one year. You know how you can set reminders on your phone? She set a reminder at 10 p.m. every night. This came up. She didn't forget it at the end of the year. I mean, that's nice, but if we did that for all the important things we need to remember in this class, you just get reminders from like 10 till 1 a.m. every day. Beep, 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 beep. You probably remember some of it, but you might stop. But anyways, she put this as a reminder, special note. Okay, yeah, I got to remember that. And every night it's like a little reminder. It's not actually if you did it the right way, it wouldn't actually be a bad study thing to remind you of things. This is one of those that you will forget. So if there is one that you'd want to remind yourself of, this would be that one. So if your equation is written and it's not in factored form, you have to take a little bit extra time and write it in factored form. Okay, questions for practice. 4, 5, and 6.